Start recording. Okay. This is, we are going to get into some things this week. We're going to do a lot of factoring. Okay. That's basically it for this week. Factoring. If you know how to factor, you're going to have a good time this week. For those of you that don't remember factoring back in Algebra 1, you might struggle a little bit. That's why we're going to review factoring. And then next week, we're going to do long division and synthetic division. I would highly recommend that you attend next week's session because it is a little bit more difficult. You probably have never seen long division with polynomials, and you've probably never seen synthetic division with polynomials. So next week will probably be very, very new. The nice thing about next week, does anybody know what the nice thing about next week is? What's the nice thing about next week? It's week 12, and it also is the last full week before Thanksgiving. And what I mean by that, since the following week is only 2 days, it's Monday and Tuesday. So you guys, for Thanksgiving, you guys get off Wednesday, Thursday, Friday. So the 2 days previous are considered week 12 still. So really next week is the last full week of school before Thanksgiving. So if you finish your material next week, if you finish all of the work for next week, you don't even have to go to school then the following week because we don't have a live e-session. We don't have anything. Yeah, so it's a kind of a cool thing to go through. All right, so let's start reviewing factoring, okay? When I factor, and I should have had a separate page before this because the first thing you do with factoring is you always factor out the greatest common factor. And what do I mean by that? For example, let's just go backwards a little bit. If I gave you something like this and I said, I wanted you to multiply this out, okay? We did multiplying last week, right? We used distributive property. What would we get if we multiplied this out? 2x squared plus 10, okay? So now, my first step whenever I'm asked to factor is I always look at the problem and I see if there's anything I can factor out. So that is always your step one when factoring is, can you factor something out? And what do I mean by that? This, we multiplied, right? So when we factor, we're going backwards. We're trying to get back to this. So the opposite of multiplying is really dividing. So when I think about factoring something, I'm thinking about, is there a number I can divide out of each of these terms? Well, I can divide a 2 out. So basically, if I divide a 2 out of this, I'm left with x squared. And if I divide a 2 out of this, I'm left with 5. So I'm factoring out a 2, and I'm left with x squared plus 5. Isn't that exactly what I started with? So when you start today, every single problem on the assessment today, the first step is, can I factor something out? Okay? That is your first thought. Now, not everything, most problems you can't factor anything out to start with, so you don't. But that is always your first step. Can I factor something out? So that's where I wanted to start. And then the next thing that you have to look at is how many terms there are. So today we're going to look at 2 terms, we're going to look at 3 terms, and we're going to look at 4 terms. Okay? So there's these types of problems that you have to be able to factor. If it's 2 terms, it's either the difference of 2 squares. The sum of 2 squares doesn't factor. So that's not even, doesn't factor at all. So the difference of 2 squares, the difference of 2 cubes, and the sum of 2 cubes. So that's what you have to look for. So a very simplistic problem for the difference of 2 squares, if I gave you something like x squared minus 9, this is the difference of 2 squares. It will always factor to the square root of the first term. Well, the square root of x squared is just x, and the square root of the second term. Well, the square root of 9 is 3. So this would be x minus 3, x plus 3. That is how the difference of 2 squares factors. always. So if I gave you something like x squared minus 16, what would that factor down to? It is a difference of two squares. This is a perfect square. This is a perfect square. So what would that factor to? X minus 4, x plus 4. Excellent. X plus 4, x minus 4. And it doesn't matter which way I write them. I could go x minus 4, x plus 4. Doesn't. You do need parentheses. There's no question about that. Okay, so what about this one here? Is this a perfect square? Is this a perfect square? And the answer is yes on both terms. What is the square root of 9x squared? It's 3x. What is the square root of 1? It's 1. So once you know that, then it's super easy. It's just going to be 3x minus 1, 3x plus 1. Difference of two squares. Now, is this a perfect square? Is this a perfect square? Yes. 4n squared is really 2n. 49 is 7. So this is 2n minus 7, 2n plus 7. So if you get the difference of two squares tonight, it should be fairly easy, right? Okay. Do you guys remember this from Algebra 1? Hopefully your teachers in Algebra 1 taught you how to factor. Difference of two squares should have came up in Algebra 1. Okay, now, difference of cubes and the sum of cubes. Some teachers teach it, some teachers do not. Okay, I do when I teach Algebra 1. I always do sum of cubes. Now, these are very similar formulas, and it's just really a formula that you're just going to plug this into. The sum of cubes means that this is a perfect cube and this is a perfect cube. What is the cube root of x to the third? It's x. What is the cube root of 125? That's 5, because 5 times 5 times 5 is 125. So the cube root of 125 is 5. So if I was going to factor this, this is the sum of cubes. So I go up here. This is the sum of cubes. It's a plus b, or the cube root of the first term, plus the cube root of the second term. Just put a plus sign in there. And then you square your first term. So remember, I always, when I do these problems, I always say, okay, so the cube root of x cubed is x. Cube root of 125 is 5. This is my a term. This is my b term. So now it's a squared. So that would just be x squared minus a times b, so 5x, plus my b term squared. So that's 25. That's how a difference of cubes, or I'm sorry, that's how the sum of cubes factors. So now, if this was x cubed minus 125, it's going to look exactly like this. The only difference, okay, is this and this. They flip. So if I did x cubed minus 25, it would be x minus 5, parentheses, x squared plus 5x plus 25. That is the only difference in the difference of cubes and the sum of cubes. So once you know how to do one of them, it's fairly easy. It's just you have to remember which one gets a plus and which one gets a minus. So in this problem, my a term is, or my cube, the cube root of a cubed is a. The cube root of 64 is 4. So if I was going to do this, my answer would be a plus 4, and then a squared minus, and then multiply these two together. So that's 4a plus this number squared. Boom, done. That's it. That is cubes. Okay. So when you're dealing with two terms, okay, two terms, that's a 4a. That's 4a. Sorry. This is an a value here. This is 4a because you just multiply these two terms together, and that gives you your middle term. Okay. So if you're dealing with two terms, it's either going to be the difference of two squares, or it's going to be the difference or sum of two cubes. So whenever I'm factoring, I always look at how many terms there are. That tells me what I'm going to use. Okay, so now if we go on to three terms, okay, now three terms, there's two ways of factoring. The first one is if there's a 1 in front of the x or the square term, then it's super simple. Then all you have to do, if there's a 1 in front of the x squared term, you just ask yourself, what two numbers multiply to give you 7 that add up to middle term? Well, 7 times 1 equals 7. 7 plus 1 equals 8. So it factors to x plus 7, x plus 1. Done. That's it. Here, I've got a 1 in front of here. So what two numbers multiply to give me 10, but add up to negative 11? Well, negative 10 times negative 1 is 10. Negative 10 plus negative 1 is equal to negative 11. So those are my two numbers. X minus 10, x minus 1. Done. That is called a trinomial. It has three terms. Now, if there's a number in front of the x squared term, it's not as easy. I use what is called the cheater method. Okay, so I'm going to explain the cheater method to you guys because I think it is the most amazing way of factoring when there's a number in front of the x squared term or m squared or k squared or whatever it is. Okay, so what you do is you're going to cheat with the 7. Okay, so you're going to put 7m here, you're going to put 7m here. Now, I know that this is not correct because if I multiply this together, that gives me 49m squared. That's not my first term. It's 7m squared. So this is not correct, but that's how I do it. So I cheated with the 7. So at the end, I have to divide a 7 out. Okay, so now what's my next step? My next step, so the first step is pretty easy, right? You just put the first term in the first part of the parentheses. Second step, this is where it gets a little bit more hard, but it's not that hard. You multiply the two outer terms together. So that gives me negative 7. So just like up here, what two numbers multiply to give me negative 7, but add up to the middle term? Well, how about, yeah, 7 and negative 1. So I'm going to put 7 here, negative 1 here. Remember, I cheated with the 7, so I have to divide a 7 out of one of the parentheses. Yeah, doesn't, no, negative 7 and 1 would not work because negative 7 and 1 does not add up to positive 6. You get negative 6, right? So you have to be real careful. So now I cheated with the 7, so I have to divide a 7 out of one of the parentheses. So all I do is I take this one and it's like, okay, so that's m plus 1, 7m minus 1. I'm done. This is my factored form. Yep, order does matter. So let's try one more using the cheater method. Okay. So here I've got 3k. So first thing I'm going to do is I'm going to just set up my parentheses. So I'm going to put a 3k here and a 3k here. So I'm cheating with 3. So I'm going to divide a 3 out at the very end. Multiply my outer terms together. That gives me 21. What two numbers multiply to give me 21, but add up to negative 7? Okay, which two numbers? Multiply to be positive 21, but add up to negative 10. What would that be? Negative 7, negative 3. So then I put that in here. Good. Now, I cheated with a 3, so I have to divide a 3 out. Where did I get 21? I multiplied the two outer terms together. Yep, the two outer terms give you that number. Okay. So now I cheated with a 3, so I have to divide a 3 out. Would I divide a 3 out of the first parenthesis? No, because 7 doesn't divide evenly into 3. So I'm going to divide this parenthesis by 3. So I'm left with 3k minus 7 times k minus 1. Boom. That is factored correctly. I love the cheater method. Before, when I used to do it, I used to do this box method. That really messed up the kids. But this cheater method, man, it's like, wow, that is like, it's so cool. Nope, you only divide one of the parentheses by that number. Only one. So then you'd end up with, yeah. And it would never end up like that. You can divide both of them even. Let's say you cheated with let's say you ended up with something like 10x minus 5 and 10x plus 2. And let's say you cheated with the 10, right? Well, 10's not going to go into either of these positive evenly, right? So you can break this up. 10 is the same thing as 5 times 2, right? So you could divide this one by 5 and this one by 2. So you can divide both of the parentheses if you have to. You can break this number down. Yeah, this is like one of the coolest ones. But I have to go on because we have to get to our practice problems today. So now we talked about factoring 2 terms. We've talked about factoring 3 terms. We also have to talk about factoring 4 terms. Okay? Now this is called factoring by grouping. When you factor by grouping, so I'm looking at this problem and it has 4 terms, right? It has 4 terms. So now I can't factor like I did before because that was 3 terms. Now I have to factor differently. So this is called factoring by grouping. What do? We factor, we just put, anytime I have a parenthesis, I will make this negative. We put parentheses around here. Okay, you put parentheses around 2 terms, you put parentheses around other 2 terms. Then you factor out the greatest common factor in both parentheses. So what's the greatest common factor in this first parenthesis? Okay, what's the greatest common factor? X squared. So I'm going to factor out an x squared. If I factor out an x squared, I'm left with x plus 3. What is the greatest common factor here? Negative 4. I'm going to go with the negative 4, and I'll tell you why. If I factor out a negative 4, I'm left with x plus 3. Why did I factor out a negative 4 and not a positive 4? Because when I factor, these two things have to be the same. And if they're the same, then we factor this out because they're the same in both terms, right? So now I'm going to factor out an x plus 3. What is left if I factor out an x plus 3? This and this. Now, some of you are going to stop right there, and Mr. Shanklin's going to mark it wrong. You did the grouping right. You did the grouping right, but you're not finished. You have to continue. Look at this. This is the difference of 2 squares. It factors farther. This factors to x plus 2, x minus 2, and this doesn't factor, so I just leave it. This is completely factored of this. Does anybody know why we factor? Why do we factor? Is it just to make students unhappy? It's like, you got to factor these. Okay. And the reason we factor is because that helps us solve equations. If this was set equal to 0, and I asked you to solve this equation, well, the first thing I expect kids to do is factor. Once you got down to here, once you factor something and it's set equal to 0, your solutions are what makes the parentheses equal to 0. So my answer would be x equals negative 3, x equals negative 2, x equals positive 2. These are the solutions to this equation. That's why we factor, so we can solve really crazy equations. Binomial, I was impressed with how well you guys did binomial binomial expansion last week. It was crazy how many of you guys got those right. Okay, now this is Desmo's presentation. We got to get cruising because I want to make sure we get to every single problem on the practice because there's some tough ones on there today. All right, so let's go into the Desmo's presentation. Okay, that means I have to get into Desmo's presentation. All right, that means I need to share my screen here with you guys. And then we want to start working on these so we get all the practice problems done. All right, here is the first problem. First thing I ask myself is, how many terms are there? Okay, how many terms are in the first problem on this practice? 3, okay? Is there anything I can factor out to start the problem? Because that's usually my first question is, what is the greatest common factor? Can I pull something out? 2, I disagree with that. I can pull something greater than 2 out, 2x. So if you pull 2x out, watch what happens here. So I'm going to factor a 2x out of this thing. So that leaves me with what? 3x squared minus 2x minus 8. Okay, so now this is a trinomial that I should be able to factor. So guess what? I'm going to use the cheater method because there's a 3x there. So I'm going to put a 3x here. I'm going to put a 3x here. I'm going to multiply the outer terms together. So that gives me negative 24. What two numbers multiply to negative 24 but add up to negative 2? Oh boy, what are those going to be? 24 and 2. I can't see anybody. Negative 6 and 4. Very good. Okay, so negative 6 and 4. So I'm going to put negative 6 here. I'm going to put 4 here. I cheated with a 3, so I have to divide a 3 out. So my answer is going to be 2x, x minus 2, 3x plus 4. Whew, that's a major league factoring right there. All right. So my answer to this problem should be letter C. Letter C. All right. Let's take a look at number 2. Number 2, we have 3 terms again. First thing I ask myself, can I factor anything out? I've got 2x squared plus 4x minus 16. Okay. So I'm going to factor out a 2. Right. I'm going to factor out a 2 right off the bat. So if I factor out a 2, I'm left with x squared plus 2x minus 8. Oh, do I have to use the cheater method on this problem? Somebody just said my answer key is wrong on the practice. Let me go check. And it could be. I mean, I've made mistakes before on my practices. Nobody got back to me last night, so I thought my practices were okay. So I'm just jumping into my practice to make sure. And obviously, I do make mistakes, no question about it. I'm just going to go to problem number 1. And what did we say the answer was? Letter C? Was it letter C? Yeah, that's what my answer key says. My answer key says C. Let me just want to check something out here because sometimes I have it on where it rotates the answers, but it doesn't look like it. It looks like I'm right. It looks like C is correct. Okay. Yeah, but the answer is wrong on C. Okay, wait just 1 second. Let me jump back here. Let me see what we had for an answer. Okay, so the answer was 2x, x minus 2, 3x plus 4. That's the same. That's the same answer as C. It's just not in the same order, but it's the same answer. 3x. Oh, no. It's 3x plus 4, x minus 2. That is right. Letter C is exactly the same. Now, it should be 3x plus 4. Ah, that's okay. That's all right. I'd rather have you ask questions, and you were scaring me there for a bit, but that's okay. All right. So problem number 2, we factor out a 2. Do we need to use the cheater method? Nope, don't need the cheater method in this one because there's a 1 in front of the x squared. So the only thing I need to do is I need to ask myself what two numbers multiply to give me negative 8, but add up to positive 2. Okay, what two numbers multiply to negative 8, but add up to positive 2? 4 and negative 2. Excellent. So I've got x plus 4, x minus 2. And there's x plus 4. So letter B. Is that right? So letter B should be my answer. Okay. All right. Now, number 3, I'm going to stop talking because I've talked through a lot of these. So number 3, I'm going to let you guys do. So and I'm going to take attendance. So number 3, Ooh, it's 3 terms again. I would suggest to factor out the greatest common factor on this one. And then you're going to need to use, this is, ouch. Yes, this is going to be a scary one. No question about it. So try it, and then we will go back and we will look at it and see if we can work it out. Okay? I'm just going to take attendance first, and then we'll get back to it. Okay. This is where it gets the cheater method. Sometimes it's tough because when you start multiplying those numbers out, it gets a little crazy. But in this problem, I would factor out an a to the eighth. Okay, and that would leave me with 15a squared plus 46a plus 16. Okay, so now I've got 3 terms. There's a number in front of the squared term, so that means I have to use the cheater method. Okay, so when I do this, I've got a to the eighth, and then 15a, 15a, and then I'm cheating with the 15, so I have to divide a 15 out at the end. Okay. Okay, so now I have to multiply 15 times 16. All right, so 15 times 16 gives me 240. So now I need to know, is there a number that when you multiply 2 numbers together, 240, and I get 46, is there 2 terms? And 40 and 6, thank you guys, because I did not want to do this one. 40 and 6, thank you. So I'm going to put a plus 40 here. I'm going to put a plus 6 here. Now, this is where some of you ask that question. Can you divide out of the same thing? Well, I can't divide 15 out of either of them. That's not going to work. So let's break 15 down to 5 times 3. I can divide a 5 out of this one. Not a problem. I can divide a 3 out of this one. Not a problem. So I'm left with a to the eighth, and then 3a plus 8, and 5a plus 2. Is that right? Holy cow. Now, if I had to do that problem using the box method, I'd be sitting here all day long trying to figure out how to do this. Letter C. How come it's 1, 2, 3, 4? On the practice, is it A, B, C, D? Let me, I gotta go into my practice and make sure I put letters in there instead of numbers. Yes. Yeah. So we're gonna call that C. You're right. A, B, C, D. Okay, so it should be 3a plus 8, 5a plus 2. So we're gonna go with letter C in that one. Okay. Or number 3. All right. How many of you guys have seen the cheater method before? I think it is just a before, no teacher, and even when I went through college, I never learned how to factor something with a number in front of the a squared term. It just, those drove me nuts because our teachers used to say, well, just try all the different combinations. You know how many different combinations you could have for this problem? You would have just hundreds of them. And until you guessed right, that was like a guess and check thing. I did not like that. I don't like guessing. I'd rather have a straightforward method that I can use to get my answer. And this is the best I've ever seen for factoring. Back's method, I've used that also. Yep, there's other ways of doing it, but once I found this method, it was like, whew, this one's so cool. Love it. All right, number 4. Uh-oh, there's only 2 terms. So when there's only 2 terms, the only thing I'm thinking about is cubes or difference of squares. Well, this is definitely not a difference of squares, right? This is definitely a sum of cubes. Well, the formula for the sum of cubes, a plus b, a squared minus a times b plus b squared. What's my a term? What's my b term? Well, my a term is the cube root of this, so a is equal to x. And what is the cube root of 512? What is that? Anybody know? Because I don't. I could take a wild guess. 8? 8 sounds great. So my b term is 8. So now all it is just plugging it in here. That's it. So this is going to be x plus 8. And then x squared minus 8x plus 64. It's just plugging it into this formula. So what is my answer? I'm going to go with B or number 2. Okay. I cubed 8 first and got 512. That's how you do it. Yep. Very nice. So when there's 2 terms, remember it's going to be difference of 2 squares or the difference or sum of 2 cubes. All right. Question number 5. Whew. Got two terms again. So the first thing I'm looking at in this problem is there anything I can factor out? Yeah, take out the greatest common factor. What is the greatest common factor between 10v to the 11th minus 640v to the 8th? 10v to the 8th? I would say 10v to the 8th because the 8th is the highest, so or it's the lowest, so that's the most we could ever take out. So I'm going to take out a 10v to the 8th. And that leaves me with v to the 3rd minus 64. Looks like the difference of cubes. My a term is v. My b term is that 4? So now it's just plugging it in to the formula. So it's a minus sign. So this is going to be v minus 4. And then v squared plus 4v plus, what is that, 16? Boom. Whenever there are 2 terms, it should be fairly easy to do. Okay, so what is my answer here? Is that B or number 2? Yep. Yeah, Samantha, half the time I even go back and look it up and to make sure I don't have the minus signs wrong. You can look at the formulas, and that is not a problem. It's, do you know how to use the formulas? That's the key. You don't have to memorize them. I would never tell a student, you need to memorize this, but do you know how to use it? If you've got it in your notes and you know how to use it, that's what I'm looking for. You absolutely can make a sheet like that. Yes, absolutely. And the key, Samantha, as a teacher is that if you do it enough times, you won't have to look back at your formula sheet. And that's the whole process here. that if you've done it enough times, it's like, oh, I don't have to look back for difference of two squares. I know that's going to be, a minus b, a plus b. And hopefully after time that happens. But right now, we're just trying to figure out, can you use the formula to get the right answer? All right. Number 6, how many terms are there? There's 4 terms, right? There are 4 terms. So I'm looking at grouping. Yes, yes. Grouping is what I'm looking at. Now, this is where most kids are going to make their mistake. I will guarantee you this. If you don't change this minus sign to a plus sign, I'm thinking you're going to make a mistake. So what I would have done in this problem is I would have did 25s to the third minus 100s squared plus negative 9s plus 36. I'm just going to change this and make that a negative. It's going to help. Then I'm going to put my parentheses in. Okay, that would be my next step. Put my parentheses in. And then I ask myself, what can I factor out here? Well, looks like I can factor out a 25s squared. Well, oops, s squared. What's left? S minus 4. And then I'm going to pull out a negative 9. And if I did that, I'm left with s minus 4. These are the same. If they're not the same, grouping doesn't work. Okay, so I'm going to pull out an s minus 4. And when I pull out an s minus 4, I'm left with 25s squared minus 9. Am I done? No. I'm not done. Why? Because this is a difference of 2 squares. This is a perfect square. This is a perfect square. So I've got s minus 4. Whoops, I forgot my 25. Can't forget that when you factor. The 25s squared and then s minus 4. And then this factors to 5s minus 3, 5s plus 3. Uh-oh. What's wrong here? They don't have my answer. Oh, I didn't factor that out. I'm sorry. I just looked up here and thought, oh, I must have factored that out. Sorry, I did not factor that out in the beginning. Sorry. So this is my answer right here. S minus 4, 5s minus 3, and then 5s plus 3. Whew. I thought I'm looking at my answers and I'm like, oh, there's something wrong here. Yeah, panic. I did the problem wrong. No, can't happen. I'm a teacher. But I do make mistakes. There's no question about it. Everybody makes mistakes when they do math. Just part of the process. So it's B. Yeah, or number 2. That is absolutely correct. Excellent. All right. Let's try another one. Problem number 7, grouping. I'm going to let you guys work on this one by yourselves. I've done a lot together so far. So I'm going to let you guys do this one, see what you get for an answer. Okay? Give it a shot. All right. Take a look at this. If I'm looking at this problem, the first thing I think about is 4 terms. I'm going to rewrite this thing because this is where they're going to try to trick you. No question about it. This is Every time I see that, it's like, oh, they're trying to trick the kids now. So I've got 15x to the third minus 6x squared plus negative 25x plus 10. All right, I'm going to put my parentheses around here. Factor out the greatest common factor. Oh, what is that, 3x squared or 3x squared? If I pull out a 3x squared, I'm left with 5x minus 2 plus, and then I'm going to factor out a negative 5. And that leaves me with 5x minus 2. Ah, awesome. So these are the same. So that means I'm going to factor the 5x minus 2 out. Well, if I factor out 5x minus 2, what is left? 3x squared minus 5. Now, I'm not, I don't stop there. I just look at it and it's like, okay, can I factor it any farther? And this one doesn't. It's not a square, right? It's not a square. I can't factor any farther. I'm done. This is it. This is as far as I can go. 5x minus 2, 3x squared minus 5. So letter A. Do you guys agree? How many of you guys got that right? Thumbs up, thumbs down. I think factoring by grouping is not the hardest thing to do. I think the hardest one today is doing the cheater method. Anytime you have the 3 terms and you have a number in front of the x squared, I always think that those are the hardest to do. And it only takes one small error, right, Samantha? I mean, it just one thing, one minus sign, it just messes up the whole thing. But as long as you have the concept down. All right, number 8, 3 terms. Oh, I'm not a big fan of cannot be factored. I'm not a big fan when they put those types of problems in there. All right, 3 terms. Can I factor anything out? Can I factor anything out to start with? Okay, greatest common factor. What is it going to be? 5b cubed. Okay, so we know answer A cannot be factored. It can be, because we can pull, at least we can pull a greatest common factor out of there. So 5b cubed. All right, so 5b cubed. So what's left after I take out 5b cubed? Well, that gives me 4b squared plus 7b minus 2. Uh-oh. Now it looks like the cheater method, but nothing is factored any farther. So I'm going to assume that the cheater method doesn't go any farther. I'm assuming that we're done here because I'm looking at my multiple choice answers and it looks like we're done right here. So it looks like D is the answer. Now, it might factor farther. I'm looking at it. So that would give you negative 8. 2 numbers that multiply negative 8 that add up to 7. Now that wouldn't work. Negative 1 or negative positive 8 and negative 1? Huh. But we don't have to go any farther. So we're done. D is it. We're going to stop with letter D for that one. All right. Next question. It says factor by grouping. Okay, so we've got 4 terms. We've got to use grouping. I'm going to let you guys work on this one. See how you do. Oh, so small. Sorry about that, guys. Sometimes when I copy and paste them in there, they are kind of small. The one thing that I will know this week is if kids watch the practice or not, because there's no way you're gonna, I know there's some kids that just guess at the answers. There's no way you're gonna guess all, to get an 80% on these factoring problems. So, and there are still students that get unsatisfactory on the weekly practice. And it's like, how do you do that? We go through all the answers. It just boggles my mind. But it is what it is. I mean, if you don't want to watch it, that's fine. But it really does help if you watch or watch the recording, right? You find it hard to sit through the recording? Are we just not exciting enough for you? I get it. I would have a tough time sitting through a recording also. There's no question about it. All right. So, does anybody have an answer to this one? A, B, C, or D? What do we, anybody come up with an answer yet? I know I didn't give you a whole lot of time to do it. Letter A? Oh, letter A with a question mark. Number one, hey, this time it has letters. You can't use one anymore. This time the answer key has letters. All right, let's take a look at it. Are they trying to trick us this time with that minus sign? Nope. Okay, so that's a good thing. They're not trying to trick us there. All right, so the first thing I'm going to do, I'm just write down, oops, I'm going to write down 20a to the third minus 25a squared b, ooh, that looks a little tough, plus 8ab squared minus 10b to the third. Okay, that's not a hard step because it's just putting parentheses in. We don't even have to think yet. Now we have to think. What's the greatest common factor in this first term? What is the greatest common factor there? What can we pull out? 5a squared. Agreed. Very nice. I like it. So I'm going to pull out a 5a squared. That leaves me with 4a minus 5b plus. And then I'm going to factor out the greatest common factor here. 2b squared. 2b squared looks like it. 2b squared. So 4a minus 5b. They're the same. Love it. So that gives me 5a squared plus 2b squared, and then 4a minus 5b. And, oops, 4a minus 5b. Sorry about that. So 5a squared plus 2b squared, 4a. So letter A, that does look like the correct answer, doesn't it? Letter A. Ah, now I had a teacher one time where when you grouped it and you factored it out, it didn't come out nicely. But then if you rearranged the terms and then factored, it came out nicely. Those are really tough because it's like, oh, now we got to start rearranging these. I think they will all be the same. If it doesn't work, then you would just leave it. But I wouldn't do that to your guys. I wouldn't do that. I wouldn't put a problem on there that it has 4 terms and it doesn't factor, because then I'm not really teaching you how to use grouping to solve. So all of the problems that I give you, you can factor. Okay, I'm not going to put something on an assessment. I've got an assessment that wants you to learn how to factor. I'm not going to put something on there that doesn't factor. Okay, I'm just not. I mean, I could, but I wouldn't do that because that's not. I want to see if you know how to factor. I don't want to try to trick you into, oh, this thing doesn't factor. No, I wouldn't do that. Now, some of the practice problems could, because I just take these practice problems off of, wherever I can find multiple choice ones. But I don't think we had any that didn't factor out. So we'll just keep our fingers crossed that we don't run into one of those. All right. What type of problem is this? Oops, I think this is the last one. What type of problem is this? What type of factoring are we going to use? Grouping. Exactly. We're going to use grouping because it has 4 terms. If it had 2 terms, we would factor. So there's really, when you start looking at these factoring type problems, you're looking at how many terms there are. If there's 2 terms, we're going to do difference of 2 squares, difference or sum of 2 cubes. If there's 3 terms, we're going to either factor it like a trinomial or use the cheater method. If there's 4 terms, we're going to use factoring by grouping. But you always have to remember, and will I have problems on the assessment where when you factor it, it's going to factor even farther? Yes, I will tell you that there will be some that when you factor it out using grouping, that you're going to have to factor even farther. I think it's about the same, to tell you the truth. I think the formative or the summative this week is just basically, do you know how to factor? And I think the practice was very similar. I mean, we had 2-term ones, we had 3-term ones, and we had 4-term ones. So I don't think there's anything harder on the assessment. I thought, I don't know, remember what number that was, the one that had the 240 in there. That was pretty tough to do the cheater method on. Well, the first couple should always be easier. I always try to put some challenging ones for number 4. I always try to put a challenging one down there for the fourth problem. Yep, that's exactly right. That is the point of advance. Can you get, the easy ones at the top and then the real hard one at the bottom? That is absolutely correct. That's how I set up all my assessments. I try. Okay. So in this last problem here, first thing I'm going to do is I'm just going to put my parentheses in. They didn't even try to trick me on this last one. Yay. So I just have 2p to the third plus 7. Oh, that looks like a q. Q to the third. Put that inside parentheses. Oh my goodness. It doesn't even look like anything's going to factor out of there. Okay. Plus 7pq squared plus 2p squared q. Ugh, that is not looking nice. I'm looking at this first one and nothing's going to factor out of there. Could I factor a 1 out? Sure. I'm going to factor out a 1 out. Okay? Just because. All right? I factored a 1 out. Okay, now the second one, PQ? Does that look right? Factor out a PQ? PQ? This is not looking nice. So I'm going to factor out a PQ here. So that gives me 7q squared plus 2p. Huh. Whoa. That one does not look nice, does it? Yeah. Okay. So this does not look right. I mean, I'm looking at this thing and it's like, okay. It would just be 7q. For which one? So you guys rearranged it? Okay. So, and I didn't look at the practice problems. Okay. So I did not notice this one. So let's go back and let's rearrange this thing. So it, because you can rewrite anything any way you want. So I'm just going to rewrite this as 2p to the third plus 2p squared q. Is that how you guys would have rearranged it? Plus 7q to the third plus 7p q squared. All right, so that's, if I was going to rearrange it, that's what I would do. So then I would factor out a 2p here, and that would give me p plus q. Is that right? No, pq. Oh, then I could have factored out another p. What am I doing here? I should have factored out 2p squared. Okay, so that leaves me with, now I'm flustered. P plus q. All right. Plus, all right, then I'm going to factor out a 7q squared. 7q squared. That leaves me with q plus p. Now they're the same. Woo! So I'm going to factor out a p plus q, which is the same thing as q plus p, right? And that gives me 2p squared plus 2q squared. Oh my goodness. Do we get an answer here? I could factor out a 2 now, but I don't see anything up here with a 2 factored out. All right, I better look at you guys and see what you guys are saying. Okay. I'm just, I don't know if I made a mistake here. How did you get a minus sign in there? How did you get a minus sign when there's no minus signs in the whole problem? That would be the only question I'd have. Angela, I mean, I'm looking at your answer and it's like, I see a subtraction sign in there, but there's no subtraction in here. So I'm not, unless I missed something in there. All right, I'm going to go to our answer key because that problem, it says the answer is B. Now, they say the answer is B, so I'm going to go with B. I'm not, wow. I don't know where they came up with that. How did they? No clue. That's yeah, just select B. Yeah, that's I would not do that to you guys. Okay? No, I don't always go through my practice problems, so that would explain that one. I wouldn't do that. I wouldn't have a problem where you'd have to flip things around because you don't have to. Okay, so don't worry about that one. It's not going to happen. The answer is B, but as I said, I'm going to have to go back and look at that one because it just doesn't seem right. Now, Joshua said something. You factor out a 7q squared, not a 2q squared. I can't even read my own writing. That's a 7 there. Okay, so that would be 2p, that would be a 7 here, but I still don't think that's an answer up there, is there? P plus Q. I still don't see a P squared, Q squared, 7. Yeah, that is, that still doesn't look right. Something's way off there. Something is way off there. None of the answers worked when I worked backwards. Okay, so this is really a bad problem. This one is really bad. Yeah, because even if you go backwards, if you multiplied all these out, you don't get this. So someplace somewhere, somebody really made a mistake. Sorry about that, guys. I will guarantee you, I've done the answer key to the assessment this week. They all work out. you won't get into anything like this that doesn't work out like that. All right. I hate to end on a problem like this because that's not the way it should be. Okay. Any questions about any of this stuff? Only a couple minutes to go. Yes, it is B, just because. That's because that's what my answer key says. All right. You guys have a great week. Remember, we have a help session on Wednesday at 1 to 2. Last week, I think I sat there all by myself for a whole hour. I don't think anybody came last week. So it would be awesome to have some kids there. All right. You guys have a great day. Factor all the way, Nicholas, because you have to factor, if you factor it once and you end up with something that can still factor, you have to continue to factor all the way down. Yeah, you have to continue factor. So if there's something that once you factor it the first time, you still have something, you still have to go through. And there were a couple problems like that we did today, that once you finished, you have to keep going. I think even one of the first practice problems we did had something like that when you, yeah. So here, when we factored it, you have to continually factor till you get it all the way down to the whole factored form. So I think we had one that it was a difference of 2 squares once we factored it, and we had to keep going. So that's basically what it means, is that you just have to make sure that you factor it all the way down. So like this one here, we pulled out the 10 10v to the 8th, but we ended up with a difference of 2 cubes here, so we had to keep factoring. So always make sure you factor it down as far as you can. All right. You guys have a great week. Get outside today and tomorrow. It's supposed to be beautiful out. Then it's going to get colder at the end of the week. Bye.